Hi, math students. In this lesson, our learning target is identify the constant of proportionality as a linear relationship from graphs to equations. The constant of proportionality is the same as when we find the constant rate of change. Look at this xy table. Notice that along the x coordinates, our constant rate of change is adding 2. And the same constant rate of change is happening on the y coordinates. We put this together as a special ratio called slope, where we are showing the relationship between the change in the y values compared to the change in the x values. Now we can take those coordinates and we can graph them. So we have coordinates 0, 0, 2, 2, 4, 4, and 6, 6. The ratio of slope is often called the rise over the run. We can see this relationship on the graph as we rise up 2 and we run over 2. The change in the y is 2. The change in the x value is 2. We rise up 2, we run over 2. And then we can connect our points to form a line. We would write our slope as 2 over 2, or simplify to 1. In a linear relationship, the vertical change, or change in y value, per unit of horizontal change, change in the x value, is always the same. So our ratio, slope, is also often called the rise over the run. We can see that on our graph. We have several points plotted. The rise is the change along the y-axis and the change of the y values. We're starting at 2 and we change to 4. So that is a total change of 2. On the x-axis, we have our run, which also shows a change in the x value. We start at a coordinate of 2 and we change to a coordinate of 4. That is a total change of 2. So we can write our ratio 2 over 2, or simplify the slope, 2 divided by 2 equals 1. So we would write that slope equals 1. It's important for you to know that when we are using this new word, slope, it is connected to what we already have studied. The constant rate of change, or unit rate, is the same as slope. We have been practicing unit rate, which is the constant rate of change, and now we know that that is the same as slope. Let's look at this example. We're comparing number of miles to seconds. We have x values compared to y values. Notice that the constant rate of change on the x values is increasing by 1, while on the y values, the constant rate of change is that they are increasing by 5. So when we write slope, it's a ratio. It's often called rise over run. And what does that mean? The change in the y. Look at the table again. The change in the y is always 5. So we write 5 as our change in y. The run, which is the change in x, let's look at our table again. The constant rate of change for x is always 1. So we write 1 in our ratio. When we write it as slope, we say slope is 5 firsts, or simplify 5 divided by 1 equals 5. So the slope is 5. When we graph, we are going to put our points at 0, 0. We have our point at coordinates 1, 5, and we have a third point with our coordinates 2, 10. Notice that we see the constant rate of change. We rise 5, we run 1. Then we repeat. It always stays the same. We rise 5 and we run 1. And then, of course, we could take those points and connect them to draw our line. Now it's your turn to try it. Graph the data and find the slope. Pause the video and work through the problem on your own. When you're ready, press play and we'll go through the problem together. To graph the data, we have to read the coordinates. 1, 3 is our first ordered pair. So 1 is along our x-axis, and then we rise to the 3 on the y-axis, and we plot our points. Then we find the 2 on the x-axis, and we rise up to the 6 on the y-axis, and plot our points. 3 and 9. 3 on the x-axis, and rise up to the 9 on the y-axis and plot the point. So now that we've graphed the data, we're going to find the slope. To do that, we're going to look for the constant rate of change. On the x values, we're always increasing by 1. The y value is always increasing by 3. So we have found our constant rate of change. The slope ratio is often called the rise over the run. And what that means is the change along the y, and our change is always 3 on the y value, compared to the run means the change of the x values. And our x values are always increasing by 1. Now we can simplify our slope to 3. So our slope equals 3. We're going to continue to graph, but this time when we identify slope, we're going to write the equation that represents the linear relationship. Let's begin by graphing. If we look at the table, we're comparing time in hours to the number of pages. Our x-coordinates are 5, 10, and 15, and our y-coordinates are 10, 20, and 30. When we put an x and a y coordinate together, they're called an ordered pair. Let's graph 5, 10, and plot our point, 10 and 20, and plot a point, and 15 and 30, and plot a point. Now, it's not very clear to us right now if the line passes through the origin, but we can look at the constant rate of change to find out. The x values are always increasing by 5. So let's continue the pattern and go back. If we took 5 away from 5, we would have 0. So we do have a 0 as an x-coordinate. Let's compare the changes of the y value. 10 to 20 is a change of 10. 20 to 30 is also a change of 10. So we have a constant rate of change of 10 for the y values. If we continue that pattern and we take away 10 from 10, that gives us a coordinate of 0. So now we can graph 0, 0, and we can find the slope of the line. And what I want you to look at is this equation. Y equals mx plus b is the equation for linear relationships. The y and the x are variables that represent all the varying values along the x-axis and all the varying values along the y-axis. The m is that special ratio called slope. Let's identify what the slope is, and then we'll be able to put together our equation. So we're going to write y equals. Remember that slope means the change of the y, which is 10, over the change of the x value, which is 5, times x. And now we have to understand what this plus b means. This b is called the y-intercept. So let's label our y-axis, and let's draw a line to connect our points. The word intercept is like the word interception. And if you know a little bit about football, an interception is where the line or the path of the ball gets intercepted by a player. And that's what's happening in our graph. The path of this line intercepts or crosses the y-axis. And in this case, it's crossing the y-axis at 0. So we're going to write plus 0. Now we have some simplifying we can do. We'll copy the y equals. 10 divided by 5, we can simplify that to 2 times x. And the plus 0, we don't need to write that. So our equation for this linear relationship is y equals 2x. Let's try the same type of problem where we have to write the equation that represents a linear relationship. And let's begin by graphing. Looks like we're comparing boxes to fruit snacks. So our first coordinate pair is 0, 0. Locate that and plot your point. And one box is 5 fruit snacks, and 2 on the x-axis, 10 on the y-axis, and our last order pair is 3 and 15. Okay, so now we can go ahead and make our line. We can identify that ratio called slope by using our table of values to find the constant rate of change. So let's look at what is happening with the number of boxes. Our constant rate of change is 1. And as we add a box, we are always adding 5 fruit snacks. Okay, so now we can put that together to write our slope. Now, slope is a ratio that compares the change in the y, okay, and our change in the y is 5, to the change of the x value, which is 1. So now we can write our equation. Y equals, m is the ratio of slope, so we can write 5 first, times x, and then we have plus b. Now b is the y-intercept. Y-intercept means where does the line intercept or pass through the y-axis. It passes or crosses through the y-axis right at 0. So we can write plus 0 in our equation. Now there's a couple things we can do to simplify our equation. We're still going to write y and equals, but 5 first can be simplified to just 5 times x, and we really don't need to write that plus 0. So our equation that represents this linear relationship is y equals 5x. It's your turn to try it again. Graph the data, write the equation that represents the linear relationship. Pause the video, and when you're ready, press play and we'll go through the problem together. Let's first graph our ordered pairs. We're going to begin with the ordered pair of 1 and 8. So we're going to find 1 on the x-axis and 8 on the y and plot your point. And then 2 and 16, 3 and 24, and 4 and 32. Now let's write that equation. We need to find the slope, and we can do that by looking at our table of values to find the constant rate of change. We're comparing hours to the money that we are earning. Now, hours has a constant rate of change of 1. And our earnings have a constant rate of change of 8. So now we can put that together and we can write our slope, which is a ratio, often called the rise over the run. Now the rise is the change in the y value, and that was 8, compared to the change in the x value, which was 1. So now we can write our equation. Y equals 8 times x. And what about that y-intercept? We have to see where the line is going to pass or cross through the y-axis when x is at 0. So we can go back to our table of values and we can continue our pattern. 1 take away 1 is 0. And if we take away an 8 from 8, that also gives us 0. So our line will pass through the origin, which means that the line will cross the y-axis at 0. Now we can simplify our equation by writing y equals 8x. Now we can summarize what we've been practicing with slope. Slope is the rate of change between any 2 points on a line. So if we have points 1, 1 and 2, 3, we can write the ratio called slope, which is showing us the change in the y. The value change, 3 take away 1, is 2. We can see that on the graph. The change along the y-axis is always 2 as we rise up 2. So the change in the y value is always 2, whereas the change in the x, 2 take away 1, is always 1. And again, we can look to the graph to see that on the x-axis, we're always moving 1. Our slope is often called rise over the run. And we can see that here with our numbers. The rise or the change in the y is 2, and the run or the change in the x value is 1. And we can simplify 2 first to just 2. It's the funny finale, and I've been waiting for this one. Y equals mx plus b. It's my favorite one-liner.